Assalamu alaikum everyone, this is 9.2. Again, I hope you're all doing well. Bismillah ar-Rahman ar-Rahim. Go to the key points, student book, page 177, 177. Okay, now we need to know how would we make the reaction go faster? How would we control the rate of the reaction or the speed of the reaction? Actually, there are five ways, but you have to know only four. You have temperature, concentration, particle size or surface area, catalyst, and you have pressure, but you don't have to know pressure for your lesson, just to know that there is a fifth factor. So the main factor which affects the rate of reaction is the temperature. If you increase the temperature, the reaction will go faster. The second one is the concentration. You might think that if you have less reactants, that will make them react faster, which is not actually accurate. It's not correct. Actually, when you have a higher concentration, more particles, that will make them react faster in an unexpected way. Also, the surface area, if you have large surface area or like smaller particle size, like if you turn something into smaller pieces, if you make it smaller powder, that will make it react faster or have higher rate of reaction. The last and not least, catalyst. If you have a catalyst added to your reaction, that's gonna make the reaction go faster. And that's how every one of them works, but I don't think I should teach them this way. You're gonna get confused. So let's go talk about them in some details. Bismillah. So first, let's measure practically how does temperature affect the rate of the reaction. Clearly, if we increase the temperature, even if we're cooking something, if you're cooking it and use high temperature, it's gonna be cooked faster. So when you increase the temperature, the reaction goes faster, the rate of the reaction will be higher. Now we can design the experiment we have now. You can read the steps and details, but I'm telling you in a very simple way. You'll just add the magnesium ribbon, the dilute sulfuric acid, and you will heat them up, but you cannot heat up, or you should not heat up the sulfuric acid directly on the Bunsen burner, so you will use it in the water bath. And you will measure the temperature at the beginning, then you will keep watching the change of the temperature while the reaction is taking place. You will keep changing the temperature. You want to measure the factor, which is how would the temperature affect the rate of the reaction. So you're gonna keep changing the temperature. First, you're gonna heat it up just a little bit, and it's gonna be slow. Then you're gonna give it more heat or more temperature, and it's gonna be faster. Then more heat, again faster. So the more the heat you give the reaction, the faster the reaction goes, or the faster the reaction takes place. So let's see this practically. After we kept changing the temperature, that what happened. We're actually measuring the time the reaction takes. It should take less time to show that it became faster. And by the time we are changing the temperature. So here, the reaction time, see, when the temperature was 80, the reaction took only, I think, 0.1 or something. Yeah, almost 0.1. It was so fast, the reaction. It did not take much time at all. It took a few seconds to take place. But when we made it a bit cooler, when we made the temperature 60, see what happened? The reaction took almost half a minute. So it took longer time. So long time means it's a slow reaction. So sorry for my amazing handwriting. So the temperature here, like cool temperature, means taking longer time. Again, let's cool it a little bit. When it's 50, it's gonna take again longer time, like 0.7 or 0.8, and so on, and it will keep taking more time with less temperature. That means the reaction is taking shorter time at higher temperature and longer at lower temperature. In a very simple way, so you don't get confused, when the temperature is high, the reaction will be fast. If you want the reaction to be fast and take very short time, heat it up, increase the temperature. The more the temperature, the faster the rate of the reaction. But why? Why does a higher temperature increase the rate of the reaction? Why, if we heat something up, that will make the rate of the reaction higher, or will make it react faster? These are the particles. When you increase the temperature, you give them two main things you have to mention in your answer. First, you give them more kinetic energy or movement and more chances of successful collisions. This and this should be included in your answer, or the answer is going to be scientifically incomplete. So at a higher temperature, the reactant particles have more kinetic energy. If you heat them up, that means you make them move faster or move more or have more energy to move, which is called more kinetic energy, and they move faster. So when they move faster and they have enough energy, they will have more chances of successful collision. So for any products to form, you need to have successful collision, more chances of successful collision, and you need to give the reaction enough energy to form the new bonds or to turn into products. So in a very simple way, you have to mention the giving it energy and making it successfully collide more. And by the way, the successful collision happens everywhere, with all of the factors, with the concentration, with the surface area, and in some situation with some catalyst also. Okay, the second way to increase the rate of the reaction is to control the concentration, to make it more concentrated. Clearly, you have 2 cups of hot chocolate here. Clearly, this is the more concentrated one because it's the darker. So concentration is actually the amount of solute you added to a specific amount or specific volume of a solvent. So in a very simple way, the more the concentration, the faster the rate of the reaction. We're making a reaction over here, and the sodium thiosulfate is reacting with the hydrochloric acid at specific or different concentration, and every time it produces the products at like a different time. Now let's see, after we plot them on this graph, what happens. First, when the volume of the sodium thiosulfate was 30 means high according to this experiment, the time taking was only 10 to 15 seconds. 10, wait. Anyways, like just few seconds. 15 to 20 seconds. So it took very short time. Now when you decrease the concentration, when you made it less concentrated, which is here 20, it took more time. So here it's dilute, here it's not concentrated. Again, it took longer time. So the less the concentration, the more the time it takes, means the slower the reaction. So we can see that when the concentration of sodium disulfate is higher, the time taking for sulfur to form is shorter. So that means the reaction. Short time means it's a fast reaction. So if you want the reaction to take place faster, add more particles of the reactants, as you have here with the sodium thiosulfate. So the more the concentration, the faster the rate of the reaction. Why? For the same reason, but not actually by increasing the energy, because you did not control the energy. You did not give them any energy, actually. You just give them a chance for successful collisions. What did I say? Anyway, successful collisions. You made them collide more. So, this is the situation with fewer reactants. The particles are less crowded, so they have like low chances of successful collision. Successful collision means the particles hit to form products, but they hit with enough energy to be able to form the products. So to make them get more chances of successful collision, just give them more particles. See what's going on here? More reactants, more chances of successful collision. So the faster the rate of the reaction, they're going to turn into products really fast. So fewer reactants, slow reaction. More concentration, more reactants, faster reaction, because you have more chances. You're increasing the number of successful collisions between the reactant particles, and the rate will increase. It will be fast. It will happen really fast. So if something is not going fast, just add more, make it more concentrated, make the particles hit or collide more, so they can react and form the products faster. So it's not like you used to think that if you make less reactants react, that it's gonna make them react faster. No, actually scientifically, this is not correct. You're increasing the sodium thiosulfate here, so you can get the result faster. Now the surface area, by the way, cooking is a chemical change, so we can use it for this example. Or surface area, or the size of particles. This is a large particle, so it has a small total surface area. Surface area means the area on the surface only. Like I have this pen. Now the surface area is the area only on the outside part of the pen, only on the surface of the pen. But the total area is the whole area. If I break down this pen into smaller pieces, every particle size is gonna be the surface area. So here, large particle has a smaller total surface area, so it doesn't have a big chance of reacting successfully or fast. But here, if you break it down into smaller particles, or it has like high or large surface area. Wonderful handwriting, mashallah. So large surface area means the reaction will go faster. You have the carrots here. If you cook them, a whole carrot, or you slice them, or you turn them into cubes, at which situation they will be cooked faster? Of course, the smaller, because the more surface area they have. And instead of here, if you put them only the outside where it's gonna be cooked first, then the inside, till the center. So it will take more time. But here, if you're cutting them down into smaller pieces, every piece is gonna be exposed to the heat at the same time. So it's gonna move faster and it's gonna be cooked faster. Now let's apply this on a reaction. See, you have the same setup, but you just like, once you will use the powder, and the other one you're gonna use the marble chips. So in the powder, you are increasing the surface area, you have more surface area. So the powder should go faster. Now let's see if this is happening right now here or not. You made the same exact reaction. You put the marble chips with the dilute hydrochloric acid. You put them once big or large particles and you put them again, you repeated the experiment and you put them powdered. And this is the result shown on this graph. Now let's try to put some numbers here so you can understand more. Let's just put any numbers randomly. Here the same thing. This is not just roughly, this is completely messed up, but like, you know, yeah, you got the point. So let's choose any point here at a specific volume here, and the same volume here on graph A and graph B. For the powdered ones, for 30 cubic centimeters of carbon dioxide, it took, let's say, 8 minutes. For the same amount of marble chips, it actually took maybe 12 or 13 minutes. So it took here short time and here long time. Short time, that means it was fast. So using powder took shorter time, so faster reaction. Or the one here on the top, it's gonna be the fastest one, or the powder one is gonna be the fastest, but like I'm proving it for you. So for the same volume, when it was powdered, it took only 8 minutes. When you turned into, when it was like big, large particles, it took 12 or 13 minutes, so it took more time. That means the powder took 8 minutes only, it was fast, it was having more surface area, so again the same thing, it had more chances of successful collisions between the particles, and the rate of the reaction will increase because most of the reactant is exposed to the other reactant and available to react. So they are not covered in something like these carrots, they are not covered inside, they are all exposed. You give them more surface area so they can all get exposed to the other reactant or the heat at the same time. Now, adding a catalyst. Adding the catalyst is actually lowering the activation energy. See, for any reaction to take place, it needs something called activation energy. Activation energy is the minimum energy required to start a reaction. Any reaction needs a specific energy to start, called the activation energy. And it's different like among the reactions. But here, what if I have a reaction and I use a substance called a catalyst? A catalyst, instead of needing this much energy to start for the reaction, it starts the same reaction only with this much energy because it uses an alternative pathway, and it gives it depends on the catalyst and the reaction, but like it gives it a shorter pathway to react and to form the products. So instead of needing this much energy, this much activation energy to happen, it just makes it need this much less amount of energy, so faster reaction. So adding a catalyst, when you add a catalyst, that actually lowers the activation energy and speeds up the chemical reaction, but it will remain chemically unchanged, so nothing is gonna happen to it. And you have catalysts inside your bodies called enzymes. If you remember what were enzymes from the digestive system topic, they are actually catalysts, but they are biological catalysts. Like they speed up the chemical reactions inside your body, and they are again the same thing. They remain chemically unchanged. Do you know when you have a car and it's not moving and you need someone to push it to move? There is someone who's gonna come, push the car, and go out without any change to it, or without getting involved in like the movement of the car or whatever. Just hell can go. So the catalyst is the guy who pushed the car and go. He actually the catalyst only are gonna be only added to the reaction, speeding them up, and they remain chemically unchanged. Nothing happened to them. They don't change. So they go in and out, speed up the chemical reaction by lowering the activation energy and giving the reaction an alternative pathway, easier pathway, or lowering the activation energy if you want to make it easy for yourself. So these are the main points that you need to understand for 9.2. You still need to go through the topics, but I hope that helps. Assalamu alaikum wa rahmatullahi wa barakatuh. I wish you all the best in your exam. Assalamu alaikum.